Are we rolling? Yes? Yes, yes, good morning, good afternoon, guys and boys. My name is Dr. Zangfreud. Yes, today we're going to learn about a very famous 17th century mathematician and scientist called Daniel Bernoulli. Yes, now Daniel Bernoulli was very famous for discovering the way air and liquid moves. Yes, he understood this very well. He called it the Bernoulli principle. Yeah. Okay, now we are going to get Mr. Scientist Sam to explain to you in more detail how Bernoulli's principle works. Yes. Now, I'm going to introduce you Mr. Scientist Sam. Mr. Scientist Sam, yes, he's over here somewhere. Scientist Sam? Oh, yes. Scientist Sam! Oh, yes, he's coming now. Just wait, please. Okay.
Thanks, Dr. Zangfreud. That's great. It's good to know about Daniel Bernoulli, but now I want to show you exactly how wings and aircraft fly. And as you'll see in the next few experiments, we're going to show you the effects of air pressure and how an airfoil, a wing, is going to keep your aircraft up in the sky. So let's start with some experiments and we'll see what happens when we test our own airfoil shapes. Alright, I've cut myself a small strip of paper. You can try this yourselves if you want. Cut a small strip of paper from the edge of a piece of paper, and I'm going to try a special test, and I want to ask you the question. So what's your theory? If I blow across the top of this paper, what do you think will happen? I'm going to answer that question a little bit later in the video. I want you just to think about that while you watch the next demonstrations. Now I'm going to show you something really amazing. What I'm going to do is ask you to think about what's going to happen next. And if you look over here, we've got two balloons filled with a gas called hydrogen. And I'm going to ask you to think, what will happen if I blow air between the two balloons? This is what I want you to do, is to develop what you call a theory of what you think might happen. So here we go. Are you ready? 1, 2, 3. Wow. Now, you remember before, I promised to show you what would happen if I blew across the top of a piece of paper. You should have an idea in your mind now. Perhaps you think it's going to stay like it is. Perhaps you think it's going to lift up. Perhaps you think it might come to one side or another. That's your theory. Let's test and see what happens. Are you ready? I'm going to blow across the top. That's kind of strange, isn't it? I wonder what's happening there. I'm going to explain to you very shortly why the paper is rising up. Perhaps you can think of your own idea as to why the paper is lifting up, and it's got something to do with air pressure. There we go. There it is. Here's my aircraft, and here you can see the wings of the aircraft. And in order to make aircraft fly, the wings need to be a special shape, and we call this shape an airfoil. And if you look down the side of this wing, you can see the wings have got a beautifully curved surfaces, and normally on an aircraft you have this airfoil shape in the wings, and this airfoil shape is critical to helping to make the plane fly. You will notice that the top of the wing is curved and the bottom is flat, and this is very, very important to helping the aircraft fly. And if you noticed before, when I was doing the paper experiment, the top of the paper was curved too, wasn't it? So it's a little bit like a wing, and now I'm going to show you just how the airfoil works. Okay, are you ready? Let's check it out. All right, first we're going to try the upside down airfoil. Are we ready? Wow. So as you can see, the airfoil is the only shape that actually rises up in our test support stand here. Now I'm going to show you why. Okay, now you've seen some demonstrations. Now it's time to explain how an aircraft flies using the airfoil shape. Now I'm going to draw an airfoil here. There it is, there's our airfoil shape, and what you can see here is generally what we call the profile of the wing. Now I want you to imagine that we have a small molecule of air called A and a small molecule of air called B, okay? Now the question is that these two molecules are going to have a race and they're going to finish at the line here. Now what's going to happen is that molecule air is going to zip over the top of the wing like that, and molecule B is going to zip underneath the wing, and they're going to arrive at the finish line at the same time. Now the question I want to ask you is, which one had to go faster to make it to the finish line at the same time? Was it molecule air A going faster, or molecule of air B? If you can see that A has further to travel, and therefore it's got to go faster. Molecule B could just cruise along underneath the wing. Molecule A is going to really race across the top. And when it does go faster, according to Bernoulli's principle, the pressure above the wing is lower. Molecule B is going at a very steady speed under the wing, and therefore the pressure under the wing is higher. And this in turn creates a force, and that force is the magic thing that keeps airplanes flying, called lift. And there it is. This is how a wing works. This is how an airfoil operates, and when the airfoil is moving through the air at very high speed, the force of lift is what keeps the aircraft in the sky. That's kind of cool, isn't it?
My goodness, isn't this amazing? Now, next time you go in an airplane, you can understand exactly why the airplane stays in the sky, yeah? Now we're going to show you some special things from airfoils on jets and airplanes from the TUDM Air Force Museum in Kuala Lumpur. Yes, thank you girls and boys for watching Dr. Zangfreud and Scientist Sam. We look forward to meeting you in the next exciting episode of Science Alive. Yes, see you later.